Well, hello everyone. My name is Andres. I am with OCP and Google, and I will start this presentation for SNIA. So let's load up the slides. Let's get to the beginning. Here we go. We're ready now. All right, let's get going. So presentation for the SNIA Storage Security Summit. Title is Setting the Security Standard for OCP Hardware. My name is Andres Lagar-Cavilla. I'm a principal engineer at Google. I'm responsible for platform security on our infrastructure side. And I also hold a role in OCP. I'm in the incubation committee. So what's that mean exactly? Let's talk a little bit about the OCP Foundation, its structure and organization, and that will lead into the rest of the conversation about what we do and why it matters to SNIA. OCP is divided into verticals. They're called projects. They're the projects that you would expect: networking, storage, server, hardware management, and of course, security. Security is a top-level project. Like all projects, it has two leads, and the leads are from different companies. That's very embedded in the spirit of OCP, collaboration across companies and openness. The leads for security are Nate Klein from Google and Brian Kelly from Microsoft. So the majority of the presentation today will cover what the project does in depth, its contributions, its work in progress, all that stuff. In addition to projects, there is an incubation committee. The incubation committee steers OCP, right? It creates projects when needed. It recognizes the needs and creates them. It votes on contributions. It's the last gate before a contribution is published. And it decides horizontals, strategic initiatives that last years within OCP, and that try to cover a horizontal space across many projects. For example, one of the latest proposed horizontals is an incubation lab. The incubation committee has one seat per project, and the security project is represented by me, by Andres. Foundation, of course, has staff: Archana Haylock, Bill Carter, Kelly Burdett, Kate Hendel, others. They do an amazing job, not only running the operations, but also connecting companies to projects, companies with companies, and projects with projects. Right. So a lot of the institutional tissue and making things happen actually is done by the staff. Of course, there's a board, has 7 seats. 3 of them are individuals, and 4 of them are held by companies that have platinum memberships: Google, Intel, Microsoft, Meta. So all of this structure, sort of for what, you might be asking, right? So the value of OCP particularly will speak particularly towards security, right? And I'm not trying to represent other projects here. The value of OCP that we see is that it's the only industry body where systems come together. Specifications and contributions are about systems in general, right? And there's plenty of spaces in the industry where people come together and generate specifications or algorithms, but they tend to look at, each tends to look at their own side of the elephant being a whole system coming together, right? And when it comes to security, all touch on security, some of them directly, because TCG is about security, and some of them tangentially, because the MTF or NIST these are some examples, right, in the bullet points. Think about security and generate things, but it's not the only thing that they do, right? So they all create pieces of the puzzle, but the system does not come together, right? And the role of OCP is to fill this gap and create open, accessible contributions and reusable contributions and that represent guidelines on how to put systems together for the infrastructure side of the world. Cloud providers, hyperscale providers, providers at the edge, and so on. So the project has its goals, of course, but really the main goal is to improve security of systems through open and emerging standards. We're not trying to reinvent the wheel, and even our specifications are typically not displacing other things. What they're doing is they're saying, okay, there exist these algorithms and these tools like SPDM or a TPM chip, And this is how it all comes together, right? So the last bullet point there that says use existing emerging standard is something that we feel very strongly. The other thing we feel very strongly is that security is weak when it's a fragmented ecosystem filled with bespoke products. Security through openness in and peer reviewing and reusability is a rising tide that lifts all boats. When you look at the actual slide deck, you'll see the link to the project charter and you'll be able to follow it if you're interested. So our message to SNIA within that concept is to make the security of storage devices and products boring and consistent, right? One of the parts of the spirit of the security project is that security is a base requirement, typically not a differentiator. And that is even more true as the industry evolves and everybody achieves the same, encryption capabilities, for example. So we look at a number of layers at OCP, foundational security. So our message is adopt, follow NIST 800-183 for firmware resiliency, what it means to protect, what it means to secure boot, what it means to recover, what it means to attest, and adopt structures like an internal root of trust for measurement in your devices. There are some architectural guidelines there that we can talk more when you come visit us at OCP. From an API's perspective, we really encourage the use of SPM 1.2 for attestation. Again, don't reinvent the wheel. Use emerging standards, such as Redfish, in ways that have recently come to the foreground of encapsulating Redfish SPDM or even MVMI lower protocols. We have some directional guidance, not yet sanctioned by the OCP project. They include aligning on MCTP to facilitate as a sidebar to facilitate SPDM and begin to think about PCI ID. So when it comes to our contributions and the way we slice and dice the problem space, we're really focused on NIST 800-183. It lists 3 pillars of resilient systems, and the goal is that these pillars and the requirements that emanate from those are covered by all OCP accepted and inspired products. Accepted products cover more requirements than inspired products. The pillars are protection, detection, and recovery. Protection means I'm running infrastructure at scale, and my devices are able to reject attempts for misconfiguration, right? Such as pushing, just a string of zeros as your firmware, which is obviously going to break the device. Detection is the ability to, with cryptographic strength, assert what is actually running on my devices, what configuration code is there. And recovery is when things go wrong, and they tend to go wrong not because of adversaries, they tend to go wrong because of misconfiguration or just entropy in the universe. When things go wrong, how do we leverage automated at scale ways of bringing the systems back to a clean, useful slate and avoiding manual toil? Within this context, we have released several documents, and we have many documents in progress. One of the documents we have released is our threat model. Another talks about attestation, another about secure boot. These links are all available in the slide deck, and they're for you to take a look. We also have community contributions, particularly in the place of, if you think about the recent proclamations of a software bill of materials, they're about knowing what you built and signing what you built in a way that your customers can have real confidence that there's no funny, unexpected code executing devices. So both of the community contributions, control firmware and best practices for code signing, are beginning to contribute in that space. Let's go a little bit in depth into these 3 white papers. Our threat model, of course, talks about the specific types of threats that we're mitigating, with an emphasis on not so much Hollywood-style adversaries, but just plain old misconfiguration. We're really focused on threats that are acted through remote or logical access to a system, because those are scalable and those can bring down service providers. With physical access, we are concerned, of course, but not as much because a physical adversary can naturally deny service. What we care a lot about is that a physical adversary not get access to user data. And of course, that's very that is a classic threat that the storage community has made a phenomenal effort in mitigating with encryption and rest in devices. So we also define what is out of scope, runtime attacks. You booted your device, 7 days later, somebody smashes a stack in SSH and gets in. That's not really our scope at the moment. And when we say mostly supply chain attacks, we don't care so much about people getting into your truck in transit or opening your pallet of finished goods in a warehouse, but we do care about SBOMs and that type of software supply chain. For attestation, we talked a lot about identity, which is essentially a unique entropy inside the device, how that gets mixed with other things, typically in a dice fashion, although dice is one of those things we haven't yet necessarily said that we endorse, but we're working on that, and how that through a key derivation generates an attestation key that basically is unique to this device and unique to this first mutable code. So as a service provider, you can have control and an understanding of everything that's running on your infrastructure based on those unique cryptographic identities. Then we talk about what to measure, which is typically code and configuration, such as JTAG. Is JTAG on? Can an adversary connected to this device look at raw values in registers? That would be bad. And other configuration state. And then how to securely transmit that attestation. That essentially explains the unicity of the device, how we boot it, what our configuration is. And that's where protocols like SPDM come into play, and challenges and nonces and all that good stuff. Secure boot is a foundational technology in a protection pillar. It essentially is able to reject malformed or adversarial firmware and only boot what is intended to boot by the owner. As such, the contribution talks about algorithms, talks about keys, and talks about agility or renewability, which is how do we rotate these keys when the keys get compromised or when the device has changed ownership and the new owner no longer has the keys. Circularity is a tenet of OCP, one of its few tenets, which means we really need to think about devices changing hands and a circular and a second-tier economy. Of course, preventing booting through a specific key can become, if improperly used, a denial of service vector. So we talk a lot about how secure boot failure must not render the device unrecoverable. And then in our work in progress, we talk about recovery. So these are the items that we're covering at the moment with work in progress by various contributors. Of course, recovery is one of them, which is when things go wrong, when an adversary is trying to actually push bad firmware, or when just mistakes happen. How do we prevent that? And how do we fall back to a good usable state of the into the intended state again in an automated fashion? And again, emanating from Secure Boot, we have a lot of conversations about what ownership transfer means, what impact it has on renewability of the device, and the amount of state that it needs to carry, and what impact it has on the infrastructure. Because ownership transfer scenarios may include devices powered off, or devices need to be sent to RMA and are not really responding. So it's not a simple problem of reprogramming a device. It has a lot of parts to it. And that's what ownership transfer is looking at in trying to strike a good medium. We talk a lot about, we have a secure platform overview. We talk a lot about how the system comes together. That's the document where we're trying to do that, and where we're trying to have specific and articulate recommendations about the roles of various types of root of trust in a hyperscale system, and how they all collaborate and come together to boot a system and keep it well functioning through runtime. Last but not least, OCP has a global reach. So when we talk a lot about NIST and FIPS, there's also other parts of the world that have other international standards. So we're beginning to look at that. Last thing that I'm going to talk about is we had a security checklist. And that checklist said if you comply with this and this and this, you have silver or bronze or gold. And that really didn't jive well with the community. Nobody wants to be bronze. Nobody wants the world to know that they're not gold. So we transitioned to a place where specifications templates, specification templates from OCP have the baseline of security requirements. And then the specifications say what security requirements they cover within that. And then if you're developing a new product specification, you come to the security group and we talk about it and we help you guide through it, right? So in our call to action, you can join us. This is the URL. But the thing that I wanted to highlight here the most is that we're an open group. Our mailing list is open. Our meetings are open. We meet on a weekly basis. And within those meetings, if you have a contribution in progress at OCP, you can come and discuss the security requirements and how to get there and what does it mean and why things are in the template. Source reference implementations, sort of the next step, and in line with other OCP projects like the server project with DCSCM or the networking project with NIC 3.0, which have created guidelines or prototypes or starting points for pieces of technology. We're looking at the same. And it's actually a very lively place with a lot of contributions from both hyperscalers and security vendors. This last slide is the legal you've seen. And I just wanted to close this by saying thank you very much for your time, for listening. Thank you for your interest in OCP. We welcome you with open arms. And thank you for SNIA for providing this platform and this megaphone. And please take a moment to rate this session. Thank you very much. I'm going to stop the slide deck. And thanks. Goodbye. See you around.